Yes, and we are running short of time, so let's get on to the next guest. You can read his bio at the website. I'll just say briefly that Jim Keravala is sort of a polymath. He's too long to read his entire thing, but he's building an industrial robotic workforce to undertake mining, manufacturing, construction on planetary surfaces and in space. I think that's kind of an interesting point in the context of this discussion, because we're probably going to go hand in claw with our robot friends into space, and they're going to probably maybe take a lot of the medical risk out of doing things. You know, they'll do a lot of the physical labor, so we won't necessarily be at risk, as much risk of having injuries. So I think this is a very important topic. But Jim's has extensive experience in the space industry, in the launch industry, satellite design, integration engineering. He has degrees from aerospace engineering, spacecraft engineering and physics at London, Surrey, Aachen, and International Space University, and he's been faculty at Singularity U. So, Jim.
Thanks, Rand. Hi, everyone. So as we're thinking of space and surviving with medical issues, there are a number of prerequisites we need to think about. Why are we going out into space? Well, there are three fundamental reasons. One is to ensure that we have a life insurance policy for our planet here on Earth, and our species, that we have sustainable development on Earth, that we're protecting the environment on our one planet in the one habitable zone that we know, and ultimately that we're moving out to the new frontier. Now, if we consider the World Health Organization, basically the bottom line of their definition of health in 1947, health is a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. This is, in my view, a world away from most Western social and institutional medical practices, where we wait for pathology to emerge and then try and solve it after. What we need is a much more of a holistic, broad-based consideration in our definition of health, in our approach to health here, both on Earth and in space. And I think there are lots of not only synergies, but in fact requisites that cannot be separated between Earth medicine and space medicine. And in fact, one other field of medicine that I'll touch upon a little later, which some of the speakers have already mentioned. So if we just very briefly think about the context of settlement and going out into space, there are a number of aspects that we need as a human civilization as we push out. That involves transport, energy, extraction, materials, processing, fabrication, agriculture, communications, health itself, entertainment, and organization. All of those aspects create stress on us as individuals and as communities. They take resources to undertake, and that basically means we have to undergo all of that effort to build civilization. And in any period of human development, we have really undertaken the same patterns of expansion at our civilization level, whether it's prehistoric. I mean, literally our solution to health in early days was die and perhaps provide feedstock to our colleagues and friends. And as we progressed through various ages, the pursuit always being of expansion, settlement, and migratory pressures has been the pursuit of a better life, whether it's to escape persecution, whether it's to improve your physical and environmental conditions, or for any other reasons, sometimes even through forced transit. And so for most parts, moving out into an extreme frontier has been worth the risk on the body physiologically and psychologically, because the trade-off has always been a better life. Well, in space, and especially in space in this year, this decade, and possibly for the next few decades, actually moving out into space is a tough environment. It's not the pursuit of a better life for quite a while. Even as we get into multiplanetary species, into the solar system, if you can see this chart on the right, qualitatively, our expectation of the quality of life is still going to be quite tough until we are able to accelerate technology to such an extent that we can move anywhere in the solar system, anywhere in the near galactic region. We will assume that we will have solved many physics, engineering, and human medical and augmentation technologies to enable the recovery of that delta from a good life to a better life. And so it's just summarizing that first brief context of why we're going and trying to do something. It seems like we are at a very unusual time in our civilization's history, where the next frontier of expansion does not necessarily equate to a better physical environment, a safer physical environment, more food, more proximity to fresh water, more security. In fact, almost on every level, moving out into space is somewhat the opposite of that. We do sit in the most remarkable oasis of life in this habitable zone around this little star that we know of. So as we go forward and push out, we need to overcompensate for our near-term operations in space for at least this generation and the next, before we develop the environmental technologies to enable the mitigation of detrimental health effects, and B, to develop the medical technologies necessary to survive those effects. And as we push out into space, there are a number of physiological, psychological, psychosocial factors, additional human factors and habitability strains and stresses that any individual or group of individuals will experience. And many of the speakers have given some excellent reviews of this, so you'll have this information afterwards. But just as a big picture, what we can see is that in the normal day-to-day stresses of life, even on a planet of 1G that our entire adversarial DNA evolution has adapted us perfectly for, moving outside of that environment will cause additional stresses up and down our entire being. As we then look at those stresses, environmental stresses of space, and we try to consider various stages of human habitation in space, whether it's short sorties, slightly longer duration outposts, enthusiastic and ruggedized settlement, and the die hard and perhaps die soon frontier types who will be on one-way missions to open up the frontier on behalf of humanity. As we move from those short missions to those long habitations, we can see that the existing environment gets more and more hostile as the effects of space from radiation, dust, lower gravity, a multitude of other effects take its toll on our physiology that is not used to being outside of a 1G gravity well, inside a magnetic field, embedded in an atmosphere rich in oxygen, protecting of the radiation environment, protecting us from the majority of micrometeorites and other effects of space. And so we have to figure out these solutions at a systems level to enable this. And there are great challenges. In the detail of the challenges across the board are significant in their individual status. The interaction between the cascading effects of one medical function falling or failing, and then cascading into other challenges from a medical perspective are also significant. And we have significant cardiovascular stresses with the heart. There can be greater stresses to the heart operating in lower gravity fields, changes in the rhythm of the heart due to the onset of electrical activity, the mass reduction of the heart due to muscle loss, which can then have cascading effects on the ability of the heart to provide blood flow throughout the body. We can suffer bone loss that can lead to osteoporosis, fractures, reductions in integrity in the skeletal capability, and even causing cascading effects on the musculature. The muscle loss itself can result both in mass loss and loss in strength, let alone other effects that can occur with muscles around the organs and in the torso, strains on ligaments and tendons around the skeletal structure as well. Our ability to adapt to space, to adapt in terms of space sickness, our versatility and stability within microgravity and low gravity. And if we try to even mitigate with rotational artificial gravity stations, how big do we have to make these to ensure that the net Coriolis effect doesn't affect our neurovestibular system unduly as well, basically too much constant spin. These are other effects that come into play, let alone the big unknown or the big known and the big challenge of radiation exposure, which is a constant risk, where high doses of radiation from various number of sources can, of course, cause great risk and harm both to people, livestock, agriculture, and electronic systems. And then our body ability to, for our immune systems to mitigate many of the effects of being in space. There have been a number of experiments undertaken as to where the threshold of gravity exists to ensure that the immune system maintains a certain amount of function and integrity. There is various data to show that around 1/3 gravity is ideal or required as a minimum to be able to push forward, but I think much more research has to be done in this. And of course, as humans, we are not just a collection of human cells. We take a microbiome with us as a complex symbiotic system. And there's no way of telling what changes in response to microgravity our inherent bacterial farm or zoo that we take with us will react in various directions. And then you add the challenges of fungus and viruses and bacteria into play. And we really have a lot of challenges and a lot of learning to undertake in this field. And then when you consider even then the physical trauma of injury, burns, breakages, tears to the skin, the challenges of mitigation and first aid that we operate here on Earth can be very different in space. Blood flow is different. Our ability to brace the body in repair and mitigation is different. And let alone those macro flows of blood and other fluid systems in the body, all sorts of microprocesses that are occurring at the cellular level can cause endemic and mounting changes to the body in their response to injury mitigation. So various strategies as we try to think of our mission profiles and how we build for going out into space have traditionally involved exercise and body loading devices, as we've seen on station and shuttle and other missions. A lot of experiments have been done with what medicines can we take, what is the right flow of nutrition, and of course a great deal of work has been done in maintaining a gravity field to the greatest extent possible, as well as shielding against the effects of space. And so as we go out into space, we really need to consider what our starting point is, what is our approach to pushing out and building settlements and building life out into the frontier, what are the risks we're prepared to take, and what does it actually mean to try and mitigate in the space medicine world. So it does seem that I think one of the obvious synergies is that the pursuit terrestrially of longevity medicine and longevity strategies in particular terrestrially has so much overlap with the pursuit of mitigating space medical strategies that I wouldn't say that the two are one and the same. But I think if we solve for long duration space habitation, we are a long way for solving for longevity in terrestrial and extreme environments, and vice versa. I think the pathologies and the mitigation strategies are extremely coincident. In the meantime, as we go out into space, the strategy should be to minimize the amount of plasticity that the body is subjected to, minimize the amount of change that the space environment stresses the body in its adaptation. One of the remarkable things about the human body in space, or generally, is that it's so adaptable to changes in stimuli. It is actually a bit of a detriment when the environment that it's adapting to can basically create a detrimental effect in the net result. As we move forward over the decades, machine intelligence, genetics, and even quantum computing will revolutionize medicine, I think, to the point where we break through the barrier of longevity. There will be many more integrated augmentations, I think, as Shauna was alluding to, in terms of how we use telepresence, avatars, neuropresence, and robotics to really push out the requirements of human presence in various locations to the greatest extent possible. So the more we can do with robotics and remote operations without having to have people in environments where it's just not necessary or just not literally comfortable, the better it will be for the sustained expansion of humanity. And so we should start off by treating Earth as a celestial body, consider space medicine as an actual enhancer to Earth medicine, and construct business models around that premise, which will result in longevity breakthroughs to add to the work that's being done already. And with that, we can start to build infrastructure in space ahead of human arrival and simulate Earth origin environments to the greatest extent possible. Make it literally as comfortable as possible for humans to exist. And predominantly, the ideal way is, although we may need to operate and step onto various celestial bodies with variable gravities, the ideal solution set, in my view, is just to go straight ahead and build massive colonies or settlements in space that can house thousands of people and operate as if they're living in a a meadow or a forest with 1G, protection from radiation, a balanced atmosphere, and the nutrition and well-being necessary for thriving and flourishing lives in any location in the solar system, and ultimately into interstellar operations. And for our piece of the puzzle at Offworld, we're building thousands of robots terrestrially to operate in extreme environments without humans present, in underground mines and construction sites here on Earth. And as the machine intelligence and the collaborative architectures mature, we'll then deploy these same robots into space for operations on the moon, in free space, as we start to build habitats for space settlement and build the future for longevity and expansion into the solar system and ultimately the galaxy. So with that, say thank you very much, and look forward to the panel discussion.
Thank you, Jim. Very visionary. And I hope that vision comes to pass. We've all been working to make it happen for a long time.